So this is a question on application of differential equation. So a rectangular tank has a horizontal base. Okay, water is flowing into a tank at a constant rate and flows out at a rate which is proportional to the depth of the water. So here we do some definition on the variable. So constant rate, we let the constant rate be C. Okay, since it's a tank, there is a horizontal base, we let the base area be B, and the volume of water in the tank, we let it be V. Right, then with this, then we can then after that at time t, so at time t seconds, the depth of the water in the tank is x meters. So with this, right, then we can do some we can convert some of these statements, English statements, into their mathematical equivalent. So that means the rate of change of volume of water, right, is equals to whatever amount of the rate of inflow, which is C, a constant, minus the rate of outflow, which is the proportional to the depth of the water, right? So let D be the proportionality constant, so it will be dx. Alright, then we have this first differential equation. So if the depth is 0.5 meter, that means when x equals to 0.5 meter, it remains at the constant value. That means if the depth is 0.5 meter, the depth remains at the constant 0.5 meter, is no longer changing. That means the rate of change of the depth of water when x is equals to 0.5 is 0. That means the water volume of water and the depth of water do not change, right? So when at the point when x equals to 0.5 meter, right, it sort of stay constant, because the rate of inflow equals to the rate of outflow when the depth is 0.5 meter. So when there, we also know that, okay, volume equals to base area times the depth. Volume of water equals to base area of the horizontal base of the rectangular tank multiplied of the depth of the water. So that means my rate of change of V, my change of V with respect to the depth of the water is equals to the base area, which is dV dx equals to B. Then we make use of the chain rule, because we have this all in like say this in dV dt. We want it to have we want to have dx dt, because we want to have dx dt here. So dx dt using the chain rule is just dv over dt divided by dv over dx, right? Okay, why so? Because dv over dt divided by dv dx is just equals to dv over dt times dv over dt times dx over dv. Then dv and dv will cancel to give you dx dt, right? So that will give us what we want. So, and we make use of the fact that we already know this, which is c minus dx divided by what we know about the dv dx is equals to b. So it's just c minus dx over b. Alright, so and we also make use of this idea. So dx dt, which is equals to 0 when x equals to 0.5. 0.5 is half, right? So c minus half d over b equals to 0. This means that my c must be equals to half d. That means my d equals to 2c. Okay, so so then we haven't find dx dt yet. We just know that d can be expressed in terms of 2c. So we go back to change, so that we have eliminate one variable from the equation. Becomes c minus d has become 2c because of this, and x over b. Okay, then because we want to express in this form, so c over b, c we factorize from the numerator, and b we took it out from the denominator. Then we have c over b multiplied to 1 minus 2x, right? Factorize out the c. Then we have c over b is a constant, so we have equals to k, we let it be k, like we let it be this constant, and we have 1 minus 2x inside. So how do I know that k is a positive constant? Because my c is a positive constant. My c is the rate of inflow is a constant rate of inflow into the tank is a okay, it cannot be negative rate of inflow, so it has to be positive number. And the base area B is also a positive number, because the base area cannot be a negative number, so therefore is a positive constant, so therefore K must be a positive constant. So then inside this is 1 minus 2x. To change it to 2x minus 1, I have to multiply a negative, and then we have shown what they want us to show. So then we begin to collect other information here. So T equals to 0. When T equals to 0, depth of water is 0.75 meters. So I write this down. T equals to 0, my depth x equals to 0.75. This is my style of working for application of differential equation. We always like to collect the information into their mathematical equivalent, so that we don't have to keep reading this paragraph, which may be hard for the mind to process. We like to process formulas instead. So 0.75, so dx dt, right, then is decreasing at the rate of 0.01 meter per second, right? So what is decreasing? The depth is decreasing, and the rate of decrease is dx dt, right? Rate of decrease of depth of water is that at t equals to 0 equals to minus 0.01, decreasing, therefore it has a negative sign. Okay, so then find the time at which the depth of water is 0.55 meters. So that this is what we want to find. We want to find the time when x equals to 0.55 meter. This line just means when. So equals to what? What do we want to find? So this is very clear what we want to find. So dx dt. Okay, so then we come back to this differential equation, this which will help us find what we want to find, because we want to solve this first so that we can express x in terms of t. Okay, so then we solve this. To solve this, we just bring all the x over to the side of the x. So divide by 2x minus 1 on both sides. I get 1 over 2x minus 1 on the left hand side, and minus k stays. So dt is multiplied over to the other side, and then we integrate, right? Think of it this way to solve differential equations. Then after that, I bring out a half, and essentially this is what I'm trying to do. I do half and 2, so they will give me back to the same equation. Then this is in this form, so that whenever the numerator is the derivative of the denominator, we can use the integration technique ln the denominator. Okay, so actually this could be a round bracket, because we know that the depth of our water decrease to the minimum at the furthest the shortest length of the shortest depth of water is 0.5 meter, because it can't go lower than that, because it will become constant at 0.5 meter. So 2 multiplied to 0.5 is 1 minus 1 will be 0, so that means 2x minus 1 is always a positive constant, so we can do away with the modulus sign if we want to. So then when we multiply 2 over to the other side, so minus k, when you integrate, you get minus kt plus c, where c is an arbitrary constant. So when we multiply 2 over to the other side, it becomes minus 2kt plus 2c, and we need to exponential both sides because we want to get rid of this ln. So we get an exponential of minus 2kt plus 2c, and the ln disappears over here. So 2x minus 1 equals to this. Then to get my x, I add a 1. Okay, so how do I get this in the first place? So e minus 2kt is still here, notice. So when am plus n equals to am times an, this is the exponential rule. So this is essentially e minus 2kt multiplied to e to the power of 2c. E to the power of 2c, I let it be a, because e to the power of 2c is a constant, e to the power of 2c is also a constant. We just let a be that constant. A equals to e to the power of 2c. So a e minus 2kt came from here. Then I add a 1, because I bring this 1 over. I want to make x the subject of formula. I bring this 1 over. Minus 1 become plus 1. And then I divide by 2. So I get x equals to this term. So then I will try to, this term has 2 unknown constant. We'll try to solve for this using the information provided to us. So when x equals to 0.75, the t equals to 0. So t equals to 0, e to the power of 0 is 1, so I left with a inside. A plus 1 then half. So this when this is 0.75. So then 2 multiplied by 0.75 is 1.5. 1.5 minus 1 will give me 0.5. So I know that my A equals to 0.5. Next, I make use of this to solve for my K. So knowing that my A equals to 0.5, okay, I just change it. Okay, so let's go back to this again. Then we have to go back to this because this is using dx dt, so I have to come to here. So when dx dt equals to minus 0.1, so this equals to minus 0.1 and equals to minus k multiplied to 2 when t equals to 0. Okay, when t equals to 0, I also know that the depth of water is 0.75 meter, right? So the x is 0.75. Okay, when t equals to 0. So in other words, this is equals to dx dt when x equals to 0.75, because when x equals to 0.75, t equals to 0, so these two are equal. Then so I'll just make this equals to minus 0.01 minus k, 2 multiplied to x equals to 0.75, so multiply to 0.75 minus 1, okay, over here. Then we have k, then we try to solve for k. So 2 multiplied by 0.75 is 1.5. 1.5 minus 1 is 0.5. So 0.5 is just half. In order to get rid of the half, I multiply 2 on both sides. This becomes minus 0.02, and this is minus k. Minus k goes to minus 0.02, so k equals to 0.02 by multiplying a negative 1 on both sides. So then here we have our k, I have my a, I substitute back into this equation that we obtained, and we have x equals to half a 0.5 and e to a power of minus 2 multiplied to 0.02. So minus 2 multiplied by 0.02 is just minus 0.04 t plus 1. Okay, so then we have this. Once we have this equation, it's easy to find t. It's easy to find t when x equals to 0.55. I just substitute 0.55 into this equation. Alright, and I have 0.55. 0.55 to get my t, 0.55 I multiply by 2, so I have this thing. Over here, and then after that, after I multiply by 2, I must minus 1, because bring this 1 over to the other side is minus 1, and then I need to divide it by 0.5, so that I get what is left is e minus 0.04t equals to this part. And to get rid of the e, I ln both sides. That's why how this ln came about. Then I have minus 0.04t left. Minus 0.04t, to get t, I divided by minus 0.1. I divide by 0.04 minus 0.04. So then I get my t, and then just to calculate this value, to compute this, we just input into the calculator, and then we get 40.2 seconds. That is exactly the answer given. So we are done for this question.